So this week, Wednesday, we have a scheduled, I believe it's a pep rally. Is that correct? Let me pull up the bulletin. So we are having class all week long. I looked at the bulletin, but I sometimes forget to go on to the other pages. So when we look at the other pages, there's some days that are happening this week all the way through the 17th. Some fun little things that they're doing. I don't know how you get to do that, but you can read the details. On Wednesday, we have the pep rally, and we're following either first lunch schedule or the second lunch schedule. If you're, I believe you guys do the first lunch schedule. Is that correct? Yeah. All right. So you'll be here at 12:25 on Wednesday. Let me go ahead and switch the screen over so you can see what I'm looking at. I don't know why it's not. Oh, there it is. So what I expect to see is we're going to have 12:25 to 1:11. So we're going to have something like 45 minutes on Wednesday. And then your pep rally says from 2 to 3. There might be a change, Ms. Pressa. There might be a change, so it might be earlier. I'm not sure how that's going to work. I don't know the detail. It might be a correction in your Jupiter. Please pay attention to Jupiter. But that's for Wednesday. Thursday and Friday schedule. Where's Thursday? Well, Thursday is just a 15-minute early for 7th period, I think, because there's a basketball game between Arts and John Hay, and that's happening at 3. But they're letting people out with tickets at 2:45 to go to the game. Is that clear? And Friday is we have the talent show. Friday. I'm not sure what. I think the schedule's correct, but keep a lookout for the bulletin. It looks like we have 5th and 6th. Then we'll have lunch. Then 7th. All right, since your first lunch still. Then at 1:30. At 1:30, you'll be going to the talent show. I believe it's everyone. So you'll be leaving for your 7th period to the talent show. I don't know if you have to take everything with you. I didn't read any kind of information. My guess is they'll be dismissing you from there. I wish I had time to read this with you. It's in the auditorium. Class is dismissed and spring break begins at 3. But my guess is that I don't know how you in the auditorium how you carry all your stuff with you. That's a lot. I think it's all 3 schools. I think it's. Yeah, I don't think so. I think you're gonna have to come back up. It's okay. So that's the plan for this week. That's Wednesday, Thursday, Friday. The 3 days are going to be different. Why don't we close our computers, take our purses and book bags off the table, and not lay our heads down. And let's close the computers without attitude. That would really be nice. Lift your head up. If you're sick, go to the office. Hello? It's okay if you don't want to be here. Just go to the office. I don't have time to go over and over trying to make you feel better about being in the classroom. Pull out your notebooks, open them up. You should have written this stuff down that we just went over. Put away your computers. Just put them away. I don't know why this is a hassle. It's just simple directions. You darling, I need you to move up here, please. Move now. Without. Okay. I'm having patience.
You keep moving me, bro.
I'm recording the lesson. I really would rather not go into this. I'm not editing it. I'm just gonna publish it the way it is. So I don't mean to embarrass anyone, but I don't have time for all this. I'm asking nicely, move to this seat. If you don't want to keep being moved, then do what you're supposed to do without question. And please,
You should be doing stuff.
could you please put away the computer, please? The third time. Just put it away. Just put away the computer. Thank you. I'm just asking you to put it away. Close it all the way. Put it away. This has wasted probably 3 or 4 minutes of our time. It doesn't sound like a lot, but it adds up. And it ruins the whole flow. You should not be having conversations. Your bag should be off the table. You should not be talking back. None of this should be happening. Thank you. And we continue. So, in any case, Wednesday, Thursday, and Friday, there are some adjustments to the schedule. But what that does, though, is it sets some goals for us that what we have to get accomplished. Today, as you can see, we're going to start with evolution. All right? And we're going to have to, in evolution, there's a whole discussion on whether we want to really, we'll talk really quickly about some of the background information on that. Tuesday, we'll continue that discussion. You have the project we're working on in front of you, all right? Wednesday, you'll get your pre-test, your pre-assessment on whether, on the material. Let's just leave it at that. Pre-assessment, all right, let's just call it what it is, a pre-quiz, all right? And then on Friday or Thursday, depending on what day you guys are Friday, you'll have your post-quiz. Remember, your post-quiz is the last big one is the last big one for the third quarter. We got to remember that Friday is the official end of third quarter. I just want to remind you that, so there's no surprises, any missing work. Look, I'm going to grade the work as best I can. And if there's any late work, if you turn in everything at the very last minute and I run out of time and I got to put grades in, then that's what's going to happen. Then that work doesn't get graded for third quarter. I'm going to grade it from when it was the earliest stuff that was turned in. Obviously, stuff that was turned in on time gets graded. The stuff that gets turned in late, I'm going to turn in I'm going to try to grade as best I can. If you don't get this late work turned in, you're going to get a poor grade on the report card. I mean, there's nothing I can do about that. So, missing work, it has two impacts. I want to remind you that first quarter. Oh, I'm so sorry. I've been writing all this. Give me a second. I forgot to switch the screen back to the iPad. Give me a second. Should have switched. All right. So as I said, and you didn't see me write it down because it wasn't on the screen, but Monday's evolution, Tuesday will continue. Wednesday will be a pre-quiz on evolution, basically the stuff that's in front of you. Thursday and Friday, we're going to have a post quiz. That'll be 500 points as the others have been. And I'll put all those in before we leave, probably today or tomorrow or the next day. So that's it. That's the last grade. So this is the end of the third quarter. It's also the beginning of a week off. You have a week spring break. You have any missing work that's not turned in. Most teachers are saying the missing late work should be done by Monday. That's honestly fair. I've given you extra time to do it, all right? I'm encouraging you to do it. But some of you are wasting time in class, and that's a problem for all of us because we don't have time to waste. And first quarter, I wanted to say, and second quarter, they got averaged. And that's what, so you get averaged. Now, I weighed, all right? I weighed the second quarter more because you had the final on that quarter. That made sense to me. That helped a lot of you. In third quarter and fourth quarter, we're again going to be, we're weighing fourth quarter more. And why? Because here you had a final for first quarter, and here you're going to have a final for the year that you know is the OST. The Ohio State test is happening then. So that's your final. So I'm weighing fourth quarter more. What that means is that you mess up their quarter, you still have a chance to bring it up because it's these semester grades that show up on your transcript. Does that make sense? It's these semester grades that are going to get on your official transcript, on your permanent record. So you're going to have a grade here. You got whatever grade you got. And you have a grade here at this semester grade. That'll be the grade you have. That's it. A, B, C, or D. Now, as we discussed until we were blue in the face, your final is going to have a big impact on your grade. On your second semester grade. And your final is the OST. So does that mean you fail if you fail the test? No, not necessarily, but it's going to be a big impact. All right? So if you mess it up, I'm not sure how we're going to finish this. We'll look at those calculations and we'll see what that impact is. The one thing I do want you to know is the OST can act as a trump card. Do you guys play spades or hearts or anything like that?
No.
Have you ever heard of a trump card?
No.
So, who said no? Okay. So, there's a trump card is a card that beats all the other cards. Okay, so you could, like in spades, a 3, a 4 beats a 3, a 5 beats a 4, etc. Except you got spades that beats them all, right? So a trump card, the OST is your trump card. And what that means is if you get a C, no matter what your grade is during the year, if you get a 3 your whole year, I'll bring it up to a C. If you did better in the quarter than you did on the OST, I'm not going to reverse it. Does that make sense? This is only going to help you. Am I making sense?
Yes.
Okay. So if you get a 4 on the OST, you get a B for the whole year. If you get a 5 on the OST, you get an A for the whole year. No matter what your grade was, I'll put those changes in. Does that make sense to you? But it's not going to reverse. If you got an A and you failed the OST, it's not going to. It'll just be whatever whatever the hit on the points are. So if you got, if you have an A, my guess is you can go down as low as a C if you do really poorly on the OST. So it could have a negative impact on your grade, depending on percentages, right? Does that make sense? And we'll get into more details as we see how many points we're able to get done by end of this semester. Are we all on the same page? So to that point, this Friday, in fact, I want to have it to you by Wednesday, is I'm going to have an OST review spring break review. It'll be extra credit, so you don't want to do it. I'm not going to force you. But I think it's a good idea that some of you do it, because some of you honestly haven't worked as hard as you could have to get these concepts in. And because I try to average it out, I drop the lowest grade in every category, because I try to give you as many points as I can throughout every assignment, and I break it up into categories. Some of you could easily miss big pieces of the OST content and still have a B or an A or a C in the class. And maybe you just don't understand something, but you still got a B or C in the class. That's okay with me, but you have to understand when you get to the OST, you're going to have those gaps. Does that make sense? So it's important we fill those gaps and we address them. That's why we're doing this OST pre and post quiz. That's why we're doing a voluntary spring break packet. You know who you are. You know how hard you worked, or what you need, what you don't need. You know that because we're doing the pre-quizzes, we're doing the post-quizzes, we're going over the material. You have the review material in the in Schoology. There's absolutely no reason why you can't be acting as the intelligent high schoolers you are and start addressing those gaps. I could just fail you and then force you to come and all. You don't react well to that either, do you? Right? So, please, work with me here. Yeah. The extra credit will go to, it'll have to go to fourth quarter probably. But remember, what did we just say? It really doesn't matter because the semester grade is what matters. Does that make sense? So let's say I add it to third quarter. It'd probably be worth more fourth quarter. Now, granted, the report card's going to show up at your house printed, and most of us don't want our parents to see a D or an F or even a C on our report cards, correct? So we want the report cards to show the best possible grade because we want to feel good and we want our parents to feel good about our work we do. I get it. And all joking aside, about getting your butt whooped, that could happen too. I would have happened in my house if I would have brought an F. I promise you that. So, but the bottom line is, the real thing is you have to worry about is, do I understand the content? Do I understand what's going on? And if I don't, how do I get that understanding? And if I'm not paying attention in class because I'm having conversations, or I'm texting on my phone, or I'm doing some other class's work on my computer, how is that helping you get the content done? You have to do what you got in front of you, get it done, and move on. And it usually all works out as long as you're doing a little bit at a time. But a lot of us have dropped the ball. We didn't do the little bit at a time, and now we're feeling the pressure. All right, let's move on. So this is Hardy-Weinberg. This is the equation that this project is based on. We talked about Gregor Mendel. Again, he's an Austrian monk. I don't know if he's Austrian. He might be Czech, but he's a monk. He lived in the 1800s. These are all males. This is Women's History Month, so you have to understand women did not have the opportunities that women have today. Most women didn't go to school. They went to elementary school, to learn how to read or write. Maybe. They went to college. If they went to college, it was probably mostly how to be a teacher or how to be a lady, right? And manners. They actually had a college for manners. Like that was it. Some women went to college, and Marie Curie, for instance, and others went to college and broke the mold anyways, but it was very hard for them. So mostly males did this work. And even Gregor Mendel did his work while he was in a monastery. But you see, we read a lot about our science science history is mostly men, but there's a reason for it. Today things are different, but be careful. Some people would like to see it go back again. So keep an eye on, on what you believe is right and wrong, and stand up for what you believe. So in any case, Gregor Mendel, as you know, described the laws of inheritance, and he did it by studying peas. Hardy and Weinberg put math to evolution. They helped us understand how populations change. Gregor looked at how things got inherited. These guys did not know what this guy discussed. In fact, he wrote his paper in a journal in his language, and pretty much very few people read it. It wasn't until years later that people read his work and said, oh, yeah, he was right. So when we talk about Hardy Weinberg, what you need to think about is this idea that they thought, what would it take for there not to be, or I should say, let me rephrase that. For a population not to evolve, right? What we call the null hypothesis, right? Remember, in science, we can't prove anything. So we have to disprove something. We try to make sure, okay, well, this is not true, so the opposite has to be true, right? How do I know it's not true? Because I have evidence to suggest it. So I use the example all the time. If I keep throwing this up and down, and I say, every time I throw it up, can I prove that every time I throw it up, it's going to come down? Can I prove that?
Yes.
Really? How?
It's coming down.
How do I know the next time it's not going to keep going up?
It's not going up, so it has to.
How do I know? The next time, no, no. There is no way I can prove, no way I can prove that every time I throw this up, it's going to come down.
No, it's not going up, so it's going.
Okay, that's what it did. I'm asking you, how can I prove that every time, 100% of the time, I throw it up, it's going to come down? Okay, I'm going to say it again. I cannot prove it. I cannot prove it. How many times, could you wake her up, please? If you're tired or sick, go to the office. They have a space for you there. You can go downstairs, but you cannot go to sleep in this class. Please? So you throw it up and down, but that goes for all of you. Don't lay your head down. Pencil should be in hand. You should be participating in this discussion. So every time you throw it up, it comes down. Well, there's no way to prove that every time I throw it up, it's going to come down. How many times does it have to just keep going up for it to disprove it? Once. Only one time do I have to throw it up and it keeps going up. And then I've disproven that rule, haven't I?
Yeah.
So it is impossible to prove something, but I can disprove something easily. All right? So then what we look at is, let's look at what it would take for something not to be evolving. A population not to evolve. By the way, a population evolves. A population. Not an individual. Individuals don't evolve. You don't start to morph into something else. That's not how it happens. Okay? It's not a movie. It's not a Marvel comic. This is reality. Populations evolve. So what does it take for a population not to evolve? If it's not evolving, if any of these things happen, then it's evolving. Do you see how that works? So we have to disprove that a population is not evolving for us to say, okay, it's evolving. Well, how do we know it's evolving? Because we know it's not evolving, right? So we have to disprove the null hypothesis. Because all we can do is disprove. We can never prove anything. All right. So what would it take for a population not to evolve? So here are the 5 things. 5 things. 1, 2, 3, 4, and 5 that have to be true for there not to be evolution. And we'll describe what evolution is in just a minute. 5 things there not to be evolution. I just want to take a step back and say this about evolution. I know some of us have issues with evolution because our religions teach us something that we feel contradicts what the theory of evolution suggests. First of all, evolution is a theory. It's an explanation of what we see. What we see is irrefutable. We see it change. We see it happen. Now, evolution explains that. That's number 1. Number 2, there's nothing about evolution that inherently says that there is no God. Okay? There's nothing evolution says there's no God. So don't think that. If you're a believer in God or a God and you think this contradicts it, that's not true. However, there might be some things in your faith that goes against the ideas of evolution. I respect that. Here's what I'm going to ask you to do. Learn the theory. Learn what it says. Be able to solve answers on a test with it. And then believe whatever you want to believe. Okay? Is that fair? You just have to understand the theory. That's the only thing you have to do as far as this class is concerned. All right? Just be able to answer questions based on this theory. You can disagree with it. Science encourages you to disagree. But the point is, make me understand it first. Okay? Yes? We're good? Okay. So, these 5 things have to be true. Otherwise, a population. How many of these things, if any of these things are not true, what's happening? Have an evolution. You see how that works? This is the null hypothesis. If all these things are true, then there is no evolution. I'm okay with that. Any of these things are happening. If any things are actually happening, any of these, this is the stuff that is happening. If any of these things happen, there is evolution because we've disproved the null hypothesis. We've disproved that nothing's happening. How are we doing? Is that all right? Is there confusion? Is there concerns? I see nothing. Is there confusion or concerns? Could you take that bag for like the 5th time and put it off the table so I see what's happening? Yeah.
Those 5 steps are to...
We're going to go through each one in a minute.
Okay, but what?
They're just 5 things that if they're true, there's no evolution. So if it's a large population, it's hard for genetic drift to occur. So I guess that leads us to the first question, is what is genetic drift? Right? What is genetic drift? I guess that's the first question. Let's talk about what genetic drift is. Have you written anything down since you've been here? Not you, Ben. Have you written anything down? So you're just sitting there. You're just not feeling it, right? I'm okay with you not feeling it. Why are you? Come step outside. Step outside. I'll be right with you. Step outside.
No.
You haven't written anything down. Let me see the other page. You haven't written anything down. Is that correct? All right. I need to know. I need you participating. I need you guys actually doing something. So there's 5 things. Now, just sit right there until I can get to you. I'm sorry. I need to worry about these other guys first. I'll be right with you. All right. I wish. Give me a second. I'm trying to look and see if there's any qualities I can use. All right. Didn't I ask her to sit right there? I did it initially, but I said just sit right there. Oh. Let me see where she went. Why? Wow, just any interruption. That's what I'm saying. Any interruption, and it's like chaos. All right. So genetic drift. Can I use an example? Is that okay? All right. So we're a population here. We got to pretend we're a population on an island, okay, or in a cave. We live in a cave, and some. Good Jesus. Why am I wasting my time? You missed a bunch of chunk of class. I hope Dalvin can fill you in. No, I'm sure you'll be thanking everybody on the pre-quiz and post-quiz this week. So, anyways, genetic drift. This is genetic drift. I'm going to give you an example, then I'll try to describe it clearly. We're a population in a cave. Only one of us has blue hair. It's a phenotype. So she has, this particular individual had a mutation, has purple hair. What is her frequency? What is the frequency of blue hair in this population? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 1 out of 25. Fair? So it's 1 out of 25 of us has the phenotype blue hair. She had a mutation, gave her blue hair. Great. That's a frequency. Is that okay with everyone? An earthquake happens. The middle of the cave collapses. We all die. Just us, right here. We're dead. We had no babies. We didn't have a chance to have babies. What about the rest? The rest of you are okay. You survive. You go on babies. What's the frequency of the blue hair in the rest of the population? 0. So we went from 1 out of 25 to 0 out of whatever the total is now, right? So that is evolution. Period. Done. It's change. The change in the frequency of alleles over time. So genetic drift is that change happening by random event. Do you agree that change is less likely when the population is large? Among us 25, that change can happen quickly. A simple falling of a ceiling, right? But when we talk about 8 billion people, right, it's harder to get that one crazy event to occur, right? Even COVID killed 2% of the population or something like that, or some percent of the population. Even COVID would have a hard time evolving 8 billion people. Does that make sense? Like it's just a random event. Just a random event. Well, COVID's not random, so it's not really a good example. If a meteor hit from outer space and took out Cleveland, what impact would it have on 8 billion people? The gene frequency of 8 billion people? Not much. Not at all, probably. It would suck for us, but not really that big a deal for 8 billion people. So it's hard to evolve a population that's really big. Yeah. Change in frequency is evolution. The change in the frequency of alleles is evolution. That does not happen easily in a large population. It happens much more slowly. And you're going to see crazy graphs when it comes to population change or rather genetic drift. So genetic drift is actually talking about random events, things that are just an earthquake happens, a storm happens. It's nothing selecting, right? It's not like COVID that selected you and not me. For some reason, you die and I survive. There's probably a reason. It probably has to do with a gene, but that's not genetic drift. Genetic drift is something that just randomly comes and hits us and wipes out some portion of the population. Yeah. Yes, if the past is there, and it is, so go ahead. So, all right. So, random mating has to be true in order for there not to be evolution. Do humans mate randomly? Oh, I bumped into someone, we have babies. Okay, I bump into this, we have babies. We bump over here, we have babies. Okay, some guys and women act like that, but for the most of us don't do that, right? There's some kind of selection going on. You select a mate. Whether it's your parents selecting it, you're selecting, whatever, right? Peacocks are a great example. Have you ever wondered why they have the male peacocks have those giant big feathers?
The bigger the feathers, the bigger the tails, the more attractive they are.
They're more attractive. There's sexual selection, right? So the females are selecting the ones with the big, it's called sexual selection. The females are selecting the larger feathers, the larger colorful feathers for whatever reason, and that's the ones that survive. That's the one that have most of the babies because those are the ones that females are selecting. Do you ever wonder why cardinals, most birds, it's the females selecting them. The males is what makes them so colorful. Cardinals, the male is very red. Do you ever notice that? The female's not so red because the male is getting selected for by how red they are. Blue jays. There's a bird that makes a special nest. I'll show you if I have time. It's really interesting that these birds will go and collect everything blue that they find and decorate the nest with all kinds of beautiful blue ribbons and blue pops. Just crazy, beautiful nest. The male, I'll show you if I can. The males make all this beautiful home to try to say, lady, you accept me? And they want the female to select them. They do a whole courtship. The birds of paradise. The males do an incredible dance. They spend all kinds of energy trying to impress the female so that the female chooses them. Those are examples of sexual selection. In those cases, mating is not random. So there is evolution going on there. All right. If it's random, it can't be selected. There can't be a selection process if you're going to have no evolution. No mutations. Mutations happen all the time. They happen naturally. Mutations are the food for evolution. So we talked about the blue hair girl. The blue hair girl, she was born. We didn't have blue hair before her generation. She's the first blue hair child in our population. Her parents had a baby, sperm and eggs. Somewhere in there was a mutation. You said it was okay for me to use you, right? So somewhere there a mutation happened. Then now we have the blue hair allele in our population. We didn't have it before. So we have a mutation that increased genetic variation, increased variety, increased genetic diversity. Do you agree? Yeah. That one allele just went from all of us having brown or blonde or whatever hair to having blue hair, being part of the gene pool. We call this a gene pool. We are a pool, like a swimming pool, of genes. of alleles. And now we got an extra one we didn't have before. Welcome. All right. So that happened because of a mutation. Something happened, an A went to a T, a G went to a C. Something happened, and an amino acid changed, and instead of the pigment in her hair giving her brown, blonde, whatever hair, now it's blue. Period. Done. That one gene is now in the population. She has babies, who knows? Maybe it's dominant. All her babies have blue hair. And if males like that and they have a lot of babies, then everybody wants blue hair, then maybe the whole population changes in a couple thousand years. Maybe everybody has blue hair in a couple thousand years. It's possible. So the point is, mutations allow for natural selection. If we all, an example of this, of no mutations is a cheetah. Do you know a cheetah? Yeah. They're what we call an evolutionary kind of dead end. They've been inbred so much, most of them have very similar DNA. Cheetahs. If they can't live in many other environments other than where they live. A lion, they'll go and live in a wolf. A wolf is a better example. Coyotes are a great example. Their natural habitat is a forest, right? Coyotes are really good. Hyenas are also a good example of this. Now, did you know coyotes go everywhere, right? They're in the cities. They'll go into garbage cans and grab food. They'll go in the woods and live in the woods. They'll live in the cities. They'll live in the suburbs. They'll go anywhere. They're adaptable. There's a population. Some of us, if we were coyotes, some of us would be able to live in the city. Some of us would be able to live in the woods because we have a good genetic diversity. When it comes to cheetahs, they can't. They all have pretty much the same genes. You change a couple things, change the environment a little bit, they can't survive. They need wide open spaces to chase down their food, and that's what they catch. You get rid of that option, they don't really have any of their individuals in their population that can survive somewhere else. Does that make sense? So genetic diversity increases the ability for natural selection to occur, which we'll talk. That brings us to natural selection. So let's look at a population. A population of triangles, and maybe there's some red triangles, and there's some dark triangles, and maybe there's some blue triangles. So it's a good variety of individuals in this population. What if there's a predator that comes along and that predator prefers orange triangles? Maybe these triangles are Dorito chips, and you're the predator, and you just love Cheeto chips, and you don't really like Blue Ranch or the Red Hots or the charcoal flavored black ones or the whatever. So you only like orange ones, so that's the ones you're going to select, right? So you go and you pick them out. What happens to this population quickly? No orange. Well, it does shrink in the short term. Can the orange ones have babies? No, because they're eaten. They're dead. So now, because the orange ones can't have babies, they're gone. So now the only ones that can have babies are these. So you pretty much are going to have more of these. You can have more reds. First of all, you already had evolution, didn't you? Because you already changed the allele frequency. But what happens over time is that the orange ones get less and less, and the others get higher and higher. Do you agree? Isn't that common sense? And that's evolution. Yeah.
Is that how extinction works?
Extinction would mean something kills all the Doritos.
Oh, okay.
That's it. Polar bears, lions, elephants are pretty much in trouble.
So is extinct animals?
They're gone. Extinct is difficult to define because do you think we know where every animal and plant is on the planet? No, we don't. No, you can go to the restroom or go to the office and get a box. You can take the pass. So when you're talking about extinction, it's a guess. When we say something is gone extinct, that means we can't find any. We can't find any in nature, so they're extinct. If they're in danger of extinction, we think that if the population gets low enough, we're worried that somebody kills them or something kills them, they're dead. It's over. That species is gone. There are species that we know are pretty much gone. The dodo is a dodo bird, was an actual bird. It's gone. I think it was in Africa, and there are no more dodos. And there's many species that have gone extinct. But that's because we haven't found them. And there's none around that we can see. Could there be a couple somewhere, a little family somewhere living quietly in some forest? Maybe. But as far as we know, there are none left. So that's extinction. Okay, that's when the whole group goes. Natural selection is when nature selects one of these. Now I said nature. Again, if you're religious, that doesn't mean that this says that there's no God, right? So keep the two things separate. This is explaining how changes happen. We know changes happen. This is an explanation of how it happens. Because this is science, we're not going to say it's God or not God or anything. We're just saying randomly, this is what happens. When environments change, then some of us are better fit to survive than others. If we hit, an example, if we hit and there's starvation going on, if a meteor hits and there's less and less food, and some of us we're competing for food. There's not that much food around. No more grocery stores. What happens to 1, 2, 3? What happens to them versus me? Y'all are gone first, right? I mean, you don't have a lot of reserves. I have plenty of reserves. I can go a couple weeks without eating. I'd be weak, but I could go a couple weeks without eating. We need water every day, every 2 days, for sure. You need water more than you need food. But for me, for 1, 2, and 3, it's over. You don't have enough reserves to survive a week or 2 without food. You know, people get stuck in caves. You've seen those movies where it's actually happened twice now. Some kids in Asia got stuck in a cave. And some miners in South America got stuck in a cave. There's a couple movies they made of it. For weeks. And they were able to get food down to them eventually. But if you spent 4 or 5 days without food, you'd be in trouble. Your body starts eating itself. I have plenty of food for my body to eat. But some of us would have less, right? So in those circumstances, I would be best fit to survive. But what if the opposite were true? What if there's plenty of food, but there's a predator that chases down the slowest of us? And I'm dead. I'm the first one gone. I won't be the first one, I promise, because I don't have to be faster than the predator. I just have to be faster than you. So I'll trip you. And I'll walk away. No, I'm kidding. But the bottom line is, though, environments change. And so what is best fit to survive changes with it. Does that make sense?
That's how doctors are.
Huh?
That's how doctors
What's not coming? Dwarfism. Yeah, that's another story. We'll talk about that.